Hello everyone, and welcome back to my channel, Debugging with K Tips. If you're new here, welcome. Today, we're starting a new video, covering day 4 of our challenge. The goal of this challenge is to build an AI agent application in exactly 7 days. We don't use any external tools, we try to do as much as possible using just Python. Day 4 is all about data validation. But before we dive in, let's do a quick recap of day 3. We set up a MySQL server and a Milvus server to store our application data persistently. Then, we wrote functions to insert new data into these databases. More specifically, we created a MySQL database for structured data, and for large text data, we created Milvus collections to store vector representations of that text, which we call embeddings. We also already implemented functions to access the data in our databases, especially the MySQL database. If you missed this part, I recommend checking the link that's on the screen now. Today, we'll start without wasting time. Our goal is to validate the data extracted by our LLM before saving it to our database. Remember, on day 2, we implemented methods and logic to extract specific information from a given text using an LLM. In this project, we are using GPT-OSS 20B as our large language model. Whenever a connected user sends a text to our application, either through the post creation form or via our chatbot, the text is sent to the language model. The model then extracts specific information that we define so we can track the user's interests and keep them engaged with our app. Right now, our implementation forces the language model to return its response as a JSON. We defined fixed keys for this JSON and instructed the model to provide values corresponding to each key. But this has a limitation. While we define the keys, we have no way to verify that the values the model returns match the format we want. Let me explain with an example. Suppose we want to extract the age and the main topics from a text. Once the model returns its response, we want the age, for instance, to be an integer, maybe because that's how our database schema is defined. Language models might return age as a string instead of a number, writing digits in words. If our database expects an integer, a response with letters can't be inserted. The same goes for the main topics of a text. Suppose a user writes a text like, "Tell me about the climate in Berlin and politics in Germany." We see that there are 2 main topics. The model might extract them as keywords, first, climate in Berlin, and second, politics in Germany. But we have no guarantee the model will return these as a list compatible with Python. It might return them as text, separated by commas. Then, we can't use it directly in our code if, for example, a function expects a list, or if our database stores these values as a list. This is where Pydantic becomes really powerful. It allows us to define a class with required and optional attributes and specify their types. Pydantic is widely used in Gen AI applications because it validates the model's output so we can safely integrate it into an application's internal logic. Let's start today's implementation. For those following this challenge, you know I use ChatGPT as my programming assistant, not just for coding, but for designing the whole application. ChatGPT has already helped us design our databases and develop the front-end using the Gradio framework. For today, I'll upload the objectives of our application into ChatGPT again to refresh its context, so it can assist me better. My accompanying text. Today, I'm starting day 4. In the previous days, we defined the function exact_data. This is the function we will optimize. I will copy it into ChatGPT. This function is called when a user sends text through our chatbot. But as I mentioned, users also interact with our app by creating posts. I'll also get the extract_post_entities function and copy it into ChatGPT. Remember that this is the function where we call our language model to extract user-related information from the text submitted through a post. After that, I add the add_post function. This function post-processes what the language model returns. This is where we insert data into the database. But as I mentioned earlier, before inserting anything into our application's database, we must validate that the data matches the types expected by the database schema. The attributes we insert must strictly correspond to the types we defined when designing the database. We cannot guarantee that a language model will always return attributes exactly as specified in the prompt. Some models can do this better, especially larger models or models with stronger reasoning capabilities. But in general, smaller language models struggle to consistently return values in a strictly defined format. Depending on our setup and available resources, we can't always choose the perfect model. That's why tools like Pydantic become extremely important. They give us control over what the language model outputs. Following the same logic, I also add to the conversation context the function that post-processes the output of the chatbot entity extraction. This function is called extract_data. I simply copy and paste it into ChatGPT, and then I ask for help implementing a Pydantic model to validate the model's outputs. As a reminder, this application uses GPT-OSS 20b. While this model is reasonably good at reasoning, it's still relatively small. So it makes sense to add an extra validation layer, especially since its output is inserted directly into our databases. I ask my assistant whether it needs the database schema definition. The answer is quite straightforward. I already have some experience building this type of application, so I immediately know that Pydantic is the right tool here. But don't worry if that's not obvious to you yet. That simply comes with time and practice. And congratulations to everyone following this challenge. By the end of it, you'll gain additional knowledge, for example about Pydantic, if this wasn't familiar to you already. Before we can use Pydantic, we need to install it. I'm not sure whether the official website shows the installation command clearly, so let's quickly check. It doesn't seem obvious, and I don't want to spend too much time searching, so I'll just look it up directly. Typing pip install Pydantic takes me straight to the correct library. If you've followed this challenge from the beginning, you know I prototype inside a Jupyter notebook. And if you're familiar with my channel, you know I usually work inside dev containers. To avoid rebuilding the container, I'll install the library directly in the notebook. I copy the installation command and run it. As part of my routine, I also add Pydantic to my requirements.txt file, so that the next time I rebuild the container, I won't lose any dependencies. The installation completes successfully, so I can delete that cell. The library is now available in our environment. We'll need to restart the kernel later, but we'll do that shortly. Now let's go back to our assistant to review the Pydantic model definition. I'll slightly restructure my code and bring the two user data extraction functions closer together. Very soon, we'll reorganize the entire application. At this point, the prototype has proven itself, and it's time to start thinking about moving toward a production-ready application. That means transferring parts of the code from the Jupyter notebook into proper backend files. Later, the notebook will mainly serve as the entry point to start the application. I create a new cell and insert my Pydantic model. Those who know me know that I always import libraries in the first cell of the notebook, so I quickly copy the import section there. At this point, we get a warning: the validator method is deprecated in Pydantic. I immediately ask my assistant to fix this. This is another example of a stale LLM response. the assistant suggests an updated solution, which is much better. The new method is called field_validator. I copy the corrected Pydantic classes and insert them into my code. Then I copy the updated versions of the data extraction functions. Until now, we were using try and except blocks only to check whether the model returned valid JSON. But we had no control over the individual fields inside that JSON. Now, by using the user entities class implemented with Pydantic, we can validate the type of each attribute. The same applies to post-entity extraction. After verifying that the model output is valid JSON, we now apply Pydantic validation. I copy the corresponding code and insert it into my notebook. Here, we need to be careful not to mix things up. One function inserts data directly into the database, so I need to slightly reorganize the logic. We encounter a small bug. I removed the raw_response variable earlier, which was only used for debugging. We can reintroduce it later if needed. Before continuing, let's take a closer look at one of our Pydantic classes. For example, the post-entities class. This class is a Pydantic model used to validate and structure information extracted from text by the language model. The topic field is optional and represents the main subject of the text. The sentiment field is also optional, but its value is strictly constrained to positive, negative, or neutral using a regular expression. The hashtags field is a list of strings used to store extracted keywords. If no hashtags are found, the list is empty by default. Thanks to this model, we ensure that the data returned by the LLM matches exactly the expected structure and types before being used or stored. Only after the model output is validated do we proceed with insertion into the database. At this point, I wonder whether it still makes sense to return the full JSON output when validation fails. We originally added this for debugging purposes, but I think it's no longer necessary. I ask my assistant to simplify the return message. The proposed solution looks much cleaner. I update the end of the function accordingly. Since we made deep changes, I clear all notebook outputs and rerun everything from top to bottom. If something is wrong, the execution should fail. Everything looks good. The Gradio frontend starts successfully, and an external link is generated. As usual, I copy the link and open it in my browser. The login gate appears. Like in previous videos, I log in as KTips, the only user in our database so far. Login succeeds, and we reach the chatbot. I submit a quick test message with the content test. The guardrail implemented on day 1 kicks in. The message is irrelevant, so the language model is not called and no entities are extracted. Entity extraction only happens when the user submits a relevant message, for example, how to create a post. This time, the response is different. Entities are extracted correctly, and the response contains our JSON object followed by the to-do we added on day 3. Similarity search is not implemented yet. The goal will be to show users content aligned with their interests in the feed, but that's not what we're testing today. What we want to verify is whether our Pydantic validation is working and whether the model output is correctly validated. I reduce the response message shown to the user. There's no need to expose this JSON. On social media platforms, this type of extraction happens silently, and that's what we want to replicate. I test again. The guardrail blocks irrelevant input. Then I submit a meaningful message, and now the response is much shorter. Perfect. Now let's check the database to confirm that insertion worked. I open the SQL Tools panel, select the agent_challenge database, and navigate to the users table. I notice that the last_login attribute is not being inserted. That should be a quick fix. I check the user insertion logic, and I suspect the issue is in the login gate. Instead of spending time debugging manually, I ask my assistant to update the function. Each time a user logs in, we should track their last login timestamp. I also provide the user's table schema to ChatGPT. The fix is simple. Since datetime is already imported, I just need to update the function. I copy the change into my code and rerun everything. I log in again as ktips. The current time is 9:14. In the database, the last_login field should reflect this. I check the table, but it's still null. Something went wrong. I double-check the function. It looks correct. There are no front-end errors. I restart the application and reload it in the browser. I log in again. This time, I see a +1 indicator on the database icon, good sign. The database was modified. I open the table again, and now we see a timestamp of 7:16, which corresponds to 9:16 local time. I'm currently in GMT+2. So the last login tracking feature is now fully implemented. We can refocus on Pydantic, which is the main objective of day 4. Since validation happens before database insertion and we're seeing no errors, the Pydantic integration appears to be successful. That concludes day 4. As I mentioned before, some days are heavier, others more relaxed. I designed the challenge this way to leave buffer time for more complex days. Even though integrating Pydantic was quick, I wanted it in a dedicated video. I hope you enjoyed this episode. I'll move on directly to implementing day 5, which will be published in a separate video. Check the description if you want to follow the rest of this 7-day challenge. Days 5 and 6 will continue the application development, and day 7 will be the final wrap-up. Days 1, 2, and 3 are already available. Feel free to check them out. During each day, I share many small insights. You don't need to understand every line of code. The goal is to learn gradually as I explain what I know and why I use certain tools. If you like this format, leave a comment. And don't forget to like and share the video if you learned something about Pydantic today. See you in day 5. Until then, happy coding and debugging with K-Tips.